Hello friends, in this series of lectures, today we are going to study another linear data structure, linked list. In the previous lecture, we studied a data structure array, which is also linear in nature. But when we have one linear data structure, why we need another data structure, linked list? So it depends upon the requirement, means what it depends upon the storage space. It depends how what is the nature of your problem. So if your size is fixed, since array is a collection of homogeneous elements of the length of the array is fixed, whereas in linked list the nature of linked list is dynamic. We have no fixation that we have to fix the size of the linked list in advance, but this is the case in array. So let's study linked list. A linked list is a linear collection of data elements. Linked list is also a collection of data elements that are arranged in a sequence. Data elements are called nodes. In linked list, we call the data elements nodes. The linked list is a data structure that can be used to implement other data structures like stacks, queues, and their variations. With the help of linked list, we can implement other data structures like stacks and queues with the help of linked list. We can also implement stacks and queues with the help of arrays, but each data structure has its own advantage and disadvantage. It's upon the user what he or she wants to implement, what are his or her requirements. So if the size of the stack and queue is fixed, so we can implement it with the help of an array. If the nature of a stack and queue is dynamic, we can implement it with the help of linked list. So linked list can be perceived as a sequence of nodes in which each node contains one or more data feeds and a pointer to the next node. So we can see linked list as a sequence of nodes. So you are seeing here a sequence of nodes. This rectangle box, we called it a node. This node contains two parts. One part contains the information of the node, means what type of data element this node is containing. Either it is containing integer, character, float, whatever data type it is containing. One portion will contain that information and the other portion contains the link to the another node. Every node points to a node of its own type, means it's a structure. We can call it a structure. Every node, we can represent every node as a structure that is divided into two parts, and each node is pointing to the other node. The second part of the node contains the address of that node that comes after it. So this is a node. Here the variable start, here start is representing the address of the first node in the list, means start is a variable that is pointing that this is the first node in the list. Here you are seeing that in the last I have written null. It is representing that null is a null pointer that represents that the node ends here. You can represent it by using null or by 0 or -1. It's up to the programmer what notification, what kind of implementation he or she used to represent null. So both arrays and linked lists can be used to store linear data of similar types. This is the similarity between arrays and linked lists, that both can be used to store linear data, means data in a sequence of similar type. But the size of the array is fixed, so we must know the upper limit on the number of elements in advance. Since we have to declare before using the array its size, so we have a constraint that before using an array we have to fix the size of the array, but this is not the case in linked list. Inserting a new element in an array of elements is expensive, means if you want to insert an element in an array, if you have to shift the elements either upward or downward depending upon the space available in the array. So but this shifting takes so much time, and and sometimes it becomes quite complicated. If the array is small, then it is okay, but if the array is large, shifting will take so much time and the complexity of the algorithm will increase. So if we compare between array and linked list, we have some points. The basic difference is array is a consistent set of fixed number of data items. Means in array the data items are fixed, whereas in linked list it is an ordered set comprising a variable number of data items. In it, it is also an ordered set, but the number of data items vary depending upon the requirement of the user. Size. The size of the array we need to specify at the time of declaration, means at compile time. But in linked list this is not the case. We can increase or decrease, we can grow and shrink the size of the linked list at the time of execution of the program. Storage allocation. Element allocation is allocated during compile time. When we declare an array, the memory according to the size of the array gets fixed at compile time, whereas element position is assigned during runtime in linked list. At the time of executing the program, depending upon the requirement, when a node is added or deleted, the memory will get allocated or deallocated to the element. Order of the elements. In an array, the elements are stored at consecutive memory locations. Means if we have an array of 20 elements, all the 20 the memory allocated to all the 20 elements will in a consecutive manner. Means if the base address of first element is 1000, then the next if the data type of the element is int, then the next base address of the second element is 1002, 1004, 1006, since it is an array, so memory is stored consecutively. Whereas in linked list, memory is allocated randomly. There is no fixed sequence that if we have 3 elements, the first element will get 1000, then 1002, 1004. This is not the case. Wherever we get free memory, the memory will get allocated to the node. Accessing the element. We can access directly or randomly in an array with the help of an index or subscript, but this is not the case with linked list. If you want to access the element from the middle of the linked list, then you have to traverse each and every element sequentially to reach that element. So traverse starting from the first node in the list by the pointer. If you want to insert and delete an element in an array, you have to shift some elements upwards or downward, so the array becomes relatively slow. Whereas in linked list this is not the case. We can easily and fastly and efficiently insert the element in the linked list. If you talk about searching, we can implement linear search and binary search with the help of an array, but in linked list we can only implement linear search. In array, memory is less required, whereas in linked list memory is more required, since in linked list we are storing the element and the address of the next element, so more space is required in linked list. Whereas memory utilization in array is ineffective. Sometimes we declare an array of 100 elements, but we use only 10 elements in that array, whereas in linked list we allocate that much memory on that we want, so memory utilization is efficient in linked list. So we have different types of linked list: linear linked list or one-way linked list, doubly linked list or two-way list, circular linked list or header linked list. So we will study linear linked list first, or one-way linked list. In linear linked list, it is also called singly linked list or one-way linked list. In this, the node is divided into two parts. Here you are saying this is a node. It is divided into two parts. First part contains the information of the element, means what type of data that node is containing, and the second part called the link field or next pointer. This contains the address of another node, means second node in the list. So this is the sequence in which a linked list is formed. If we see the representation of linked list in memory, suppose info and link are two arrays. since info is containing the information part of the node and link is containing the address of the next node in the list. Suppose our start is pointing in the element at index 9. Okay, means our list starts from here. So n is the first character in the list, and the second part of this node is containing the index of other character that comes after this node. So it is containing the address, index of other node, that is 3, or we can say address. So 3, after n, O will come, then next node address is 6, then 6 comes, the info part of this is blank, so not to worry about that. The next node after that is 11, so we will move to EE. So you are seeing that the elements are not arranged in a sequence. Every node is containing the address of next node that comes after it. So in linked list, memory is not allocated consecutively. Where the computer allocates the memory wherever it finds a free cell. So traversing a linked list means visiting each node of the linked list. Suppose let list be a linked list in memory. This is the algorithm for traversing a linked list. This algorithm traverses list applying an operation process, and process can be anything. Either you want to print the value of that node, you want to add or delete or manipulate that node, whatever you want to do with that node, that is called process. To each element of list, the variable pointer points to the node currently being processed. Means PTR is a variable that contains the address of the first node in the linked list. So we set the PTR equal to start, since start is pointing to the address of the first element in the linked list. So we initialize pointer with the address of the first node in the linked list, and we repeat this process until unless PTR is not equal to null. Means here null is representing that this is the last node in the list. So until the value of PTR, since PTR is containing the address of next node, if the address of next node is not equal to null, we will continue this 3 and 4th step. So we apply the process to the information part of the PTR, means the value present at the address PTR. When we apply the process, we will change the value of PTR by the address of next node. Means PTR becomes equal to the link of next PTR. So we will repeat this process until PTR is not equal to null. So if you want to search an element in a linked list, if the elements are arranged randomly and you want to search an element from the linked list, the procedure is, this is called search algorithm. Info and link are two arrays. The info containing the information part of the linked list, link containing the address of another node, start is containing the address of the first node in the list, item containing the value that you want to search, or location represents the location, the address of the node that contains the item, the value of the item. So list is a linked list in memory. This algorithm finds the location log of the node where item first appears in list. Otherwise, if it cannot find out the location of item, then we will set location is equal to null. Means there is no value present of this type in the list. So we will start from the first node. So PTR is equal to start, means PTR is containing the value, the address of the first node in the list. We will repeat this step until we will not search the full linked list. Means when PTR is not equal to null, if item, the value you want to search, is equal to the value present at the address PTR, then we will set the address to the location and we will exit. Means we have find the value, we will find out the address, our search is complete, so we will come out of this loop. Else we will, what we will do, else we will set the pointer to the address of the next node. Pointer is equal to link PTR. Now PTR points to the next node, and this will continue until unless we will not find the value and the address of the item that we want to search. So otherwise, if this is not the case, then location, we will set location is equal to null and we will exit. Let's see it with the help of an example. Suppose this is a linked list. PTR is containing the address of the first node in the list. Here X is pointing the last node. You can say it is a null. So if info PTR, here we want to find the location of the item 4. If info PTR is equal to 1, means the value at the at PTR is equal to 1. Since it is not equal to 4, so we will move to the next node. So PTR next node will, now PTR will point to the second node. The information at this part is 7, so this is also not equal to 4, so we will move to the next node. Again we see that the information at this is 3, so again this is not true, we will move to the next node. Now PTR is pointing to 4, this is equal to the item, so we will set PTR and the location to the address of this item. So in this way we can search an unsorted list with the help of this algorithm. Thank you.